Starting with like a baggy method, we can see on the bag, on the right top corner of the bag, we can see the date, which is today's date, and the name, a hypothetical name taken as XY Smith being one of the commonest last names. And then this is a kind of a wound tracing diagram with necrotic tissue in the center, connective tissue, you can see the bone, and M means muscle. You can see 6 to 12 position, with 6 and 12, it's a kind of a clock position. And now what we're going to do is we're going to measure the surface area of the specimen as well as surface area through wound tracing method. So this is actually our inch scale. If you see this, the width of the longest width to the highest width comes out to be nearly 3 centimeters, and if you see the longest length, it is nearly 2.9 centimeters, or probably 3 centimeters, I guess. Yes, so the surface area is, was like pre-calculated, is like 9 centimeters square. If you see the same wound on the specimen, which is a navel orange, the specimen, on the specimen, the longest length is kind of, which is also 3 centimeters if you see, and the longest width is nearly 2.9 centimeters. So the difference between the surface area of the baggy method and the surface area of the original specimen is just 0.3 centimeters, so which is very close, so that both are actually giving very accurate readings. Okay, so now we'll start with this first activity where we're trying to debride some necrotic tissue. And let me wear the gloves. And so for this method, we're going to use like a scalpel of 10 inches, and we're going to clear the area a little bit just to have some space for the debridement experiment to happen. So what we're going to do is we're going to take a scalpel of 10 and grabbing into like third and fourth finger and forearms in a supported position. And what we're going to do is we're going to go parallel to the surface of the necrotic tissue and try to shave off a little bit, one by one, very little. Don't go deep, just be very superficial. Make sure that you don't have to go deep. You can see the chunk of tissue coming off. You can see the tissue coming off. If you go deep, you'll see the white or the clear granulation tissue, which is like you're going too deep, and patient might give you symptoms of pain because you're on a granulation tissue which has a lot of nerve endings. So pretty much what you're going to do is, you can see that I've not gone deep anywhere, just a couple of places, probably here I've gone a little deep, but most of the places I've not gone deep, and I can actually, there I go a little deep. So you have to avoid going deep where you can see the white tissue, but here you can see we removed some chunk of tissue on my scalpel, and we're going to just keep it on like a white tissue, and then we're going to keep doing it just to be sure that we are not going deep, we are superficial enough, and we are removing the dead tissue without damaging or hurting patient, because if you go deep, you're going to go on the living viable tissue, causing damage to the blood vessels or the nerves, giving signs of pain and inflammation. So you can see, just going gently, you can still see some wound tissue, dead necrotic tissue on my scalpel, right? and it's pretty simple. So you keep debriding until you are able to debride the maximum of the tissue. Okay, starting with the second experiment, where we're going to debride, or probably we're going to do a kind of a cross-hacking technique, and we're going to use like a different scalpel, which is like number 15, and the holding position is like a kind of a pen holding position, right? And the key thing here is that we have to use the serrated part of the scalpel and not the most pointed part in pen holding position, with the scalpel being resting in the first web space. Make sure that your forearms are supported, and just what you're going to do is, this is an important part, you need to understand this, that you just have to go not deep enough. Make sure that you do some parallel lines and then just go perpendicular to it. So that you're not going deep, because if you go deep, and now you can see, if you go, I think went deep here, and if you go a little deep, you can see the tissue becoming a little lighter. You see that this is if you see, the tissue here is little a sky bluish in color rather than just white. So we have not gone deep, or we've not penetrated the granulation tissue. And if you see here, you can see the light bluish tissue, so we are good here. And I'm going to just show you how one more side where we have not gone. You see, this is again granulation tissue. You can see that there's a bluish, so we have not gone deep here. I'm just going to show you how, if you go deep, if you make a deep cut here, for example, you can and try to make it upside down, you can see a white tissue, which is a viable tissue. So make sure that you don't go deep. Make a parallel marks and perpendicular marks in a tick-toe fashion, and remove the tissue. Basically, cross-hatching is important because it is a method where we try to increase the surface area of the tissue, and in some cases we use the enzymatic debridement to actually, so that it can actually the serous fluid or the transudate can come superficially, and the enzymatic debridement is successful. So you can see the light bluish tissue here. If we remove slowly, and if we go here to remove it, so pretty much you can see, if I remove this, you can see the light bluish tissue, which is very distinct from the dark tissue which was there before. Very clear. If you can see here, this is actually, there's a little bit of white tissue here, but most of the tissue here is like light sky bluish or light bluish. So we have actually been pretty much successful here and able to actually remove the tissue. So we're going to start with the third part of the experiment, which is a little different, where we're trying to actually debride necrotic tissue from the muscle. So going on the back side of the wound, you can see it's a big wound in the muscle, and what we're going to do is we're going to use the scalpels and the scissor. The key thing here is that scissor would remain in the dominant hand, which is the right hand in my case, and scissor being held like this between the first and the fourth finger, and for reinforcement you'll use the index finger, and the scalpel would remain in the first web space, right, and forearms placed on the table. So what you're going to do is you're going to just make sure that the position of the scissors are facing upwards, and what you're going to do is you're going to just lift off the tissue and and you're going to make cuts. You're just lift off the tissue from the forceps, and you're going to just make like gentle cuts. Make sure that you don't cut any white tissue, because if you cut a white tissue, which means that the key thing here is always pointing upwards, the tip always pointing upwards. Okay, and then so and we're just going to show you what actually we took out by we'll cut out a little bit more just to be sure that we are using the right technique. And if you see this, it might have been a little better if we had like a support to the. So just to show you what we took out of the wound, everything's in the tissue. You can see a lot of white chunks. You can also see a lot of blue chunks, and you can see that there are a lot of blue dots. This is a big chunk, complete necrotic tissue with the dye. This is one of the other chunks, and this is one chunk. This is one chunk. So this is actually necrotic tissue, and there are some dye particles, but majorly this is actually a tissue. This is a tissue. This is a tissue. This is a little bit of tissue, and then so that's pretty much it. I think we covered most of the things. We had the snipings, so I think that's the end of the experiment and the assignment, and we enjoyed it. Thank you.